Hello class, today we're going over section 6.4, use inverse functions. So first let's go over what an inverse function is. If the composition f of g of x equals x and the composition g of f of x equals x, then g and f are inverse functions. So if you do both compositions and they both equal x, then that means that those two functions are inverses. We denote the inverse by the symbol f to the negative 1 of x. Let's go ahead and do an example on determining whether two functions are inverses. So in example 1, we're going to determine if f of x and g of x are inverse functions. What this means is that we must show that f of g of x equals g of f of x, which equals x. So we have to show that both functions, or both compositions, equal x. So let's start by finding f of g of x. So for the function f, I do 3 times x minus 2 over 3 plus 2. 3's cancel out, so it becomes x minus 2 plus 2. So we get f of g of x equals x. That's good. Now, let's find g of f of x. So in g of x, I'm going to replace the x with 3x plus 2. Then I'm going to put the minus 2 over 3. So on top, 3x plus 2 minus 2, those 2's cancel out, so you get 3x divided by 3. So it's equal to x again. This is good. Since both of those equal x, they are inverses. So yes, g of f of x and f of g of x are inverses because g of f of x equals f of g of x, which equals x. So that's all you have to do is find both compositions, see if they equal x, and if they do, then they are inverses. Now, if you're asked to find an inverse of a function, so they give you a function, they want you to find the inverse, the steps to do that are right here. So first, you're going to swap x and y. So you'll make x y, and you'll make y x. Then you'll solve for y, and then you'll rewrite it. Instead of putting y, you'll put f to the negative 1 of x to indicate it's the inverse. So for example 2, it says find the inverse function of f of x equals x cubed plus 1. Remember, f of x is the same as y. So if I write it as y equals x cubed plus 1, and then swap the x and y, right, because that's the first step, I get x equals y cubed plus 1. After you swap those two letters, you need to solve for y. So I'm going to subtract the 1. This gives me x minus 1 equals y cubed. And then to get rid of the cubed, I'm going to do both sides to the power of 1/3. So x minus 1 to the 1/3 power equals y. Now we do need to rewrite this with f to the negative 1x to indicate it's the inverse. So x minus 1 to the 1/3 equals f to the negative 1x. And then you're done. In example 3, we're going to find another inverse. This time we're going to find the inverse of f of x equals 9x minus 6. I'll go ahead and write f of x as y, because remember f of x and y are essentially the same thing. And then I'll go ahead and swap the y and the x, so it becomes x equals 9y minus 6. Okay, so I swapped the two letters. Now I solve for y. I'm going to add 6 to each side. X plus 6 equals 9y. And then I'm going to divide everything by 9. So x over 9 plus 6 divided by 9 can be simplified to 2/3. And then remember your final answer is to change that to the inverse function notation. So f to the negative 1x equals x over 9 plus 2/3. All right, so for the last part of our notes today, we're going to go over graphing inverse functions. So when you graph an inverse, it's a reflection over the line y equals x. So what this means is that x and y values are swapped. Okay. Now, the horizontal line test that we're talking about next is to decide if the inverse is a function. So once you graph the function, the inverse, to decide if it's a function, you draw a horizontal line. If the line only hits that inverse graph once, then it is a function. Okay, so in example 4, we're going to go ahead and graph the inverse of f of x equals 3x minus 1. So what you can do is you can start by graphing the actual equation they gave you. So for that one, it starts at -1 and your slope is 3. Okay, but for the inverse, we need to take all of those points and we need to swap the x and the y values. So as an example, that y-intercept is 0, -1. So for the inverse, we're going to swap it. It's going to be -1, 0. For this next point here, it's -1, -1, 2, 3, 4. So we would swap it, and it'd be -4, -1. For the one above the y-intercept, that point is 1, 2. So to swap it, we would do 2, 1. So notice how I'm just swapping all these points. And that gives us our inverse function. So the black line is our inverse. And that's it. So you just go ahead and swap the x and y values for the function they give you, and that'll be the inverse graph. If you have any questions on today's notes, make sure you contact your teacher.